So section 1.4 is looking at negative and fractional indices, and we're looking at the laws of indices. A to the power of 1 over m equals, it's the same as the m root of a. So let me explain. If I have 25 to the power of a half, this is the same of the second root of 25, which is basically the square root of 25. We never write the 2. So it's square root of 25, which is 5. Or negative 5, because there's usually 2 answers in the square root, but we're only going to look at the positive answers. If I have something like 27 to the power of a third, this is the cube root of 27, which is 3. If I have something like 16 to the power of a quarter, this is the same as the fourth root of 16, which is 2. And if you're just using numerical values, there's no letters, you can just use a calculator. You can put something like 16 and then use the X with a box button to put a power, and then use the fraction button to make that power a fraction and put it in and press equal, and it will give you certainly the positive answer. There isn't a negative answer for each one. You have to recognize that the even numbers will give you 2 answers, a positive and a negative, and the odd numbers will only have 1 answer. But mostly we are looking at the positive answers. For this one, it's a to the power of n over m, and that gives us the m root of a, so the bottom is the root, and then that answer is then to the power of n. So the denominator is the root, the numerator is the power. So let me put something like this: 125 to the power of 2/3. Well, the 3 is the root, so it's going to be the cube root of 125, all squared, all to the power of 2. So this would be 5. The answer to the cube root of 125 is 5, but the 5 is squared, so the final answer is 25. And again, you can use your calculator if it's just a number. And I might put one more: 16 to the power of 3 over 4. That means that's the root, that's the power. So this means the fourth root of 16, all cubed. Well, the fourth root of 16 is 2, and 2 cubed is 8. So that's your final answer. Now, when the power is a negative, it turns the base into its reciprocal. That means it turns it into 1 over that base number. So let's put, for example, 5 to the power of -1 turns the 5, so the base number, the 5, into a fraction, 1 over the base, to the power of the positive power. So 5 to the power of 1 is simply a 5th. If it was 5 to the power of -2, this 5 will become 1 over 5 squared. Now, it is actually everything that is squared, so the whole thing is squared. So it's 1 squared and 5 squared, but 1 squared is still 1. 1 to the power of 10 is still 1. 1 to the power of 100 is still 1. So that is why I write the power only for the denominator. So the final answer is 1/25, and so on. Well, what happens to a fraction when there is a negative power? the reciprocal of a fraction, 1 divided by a over b, results in this fraction becoming, or the whole thing becoming, b over a. So the fraction turns upside down, and because a and b are numbers bigger than 1, the power, the positive power, just the m, is applied to both. So I'm going to put 2/3 to the power of -1 to start with. Well, that's going to give me 3 over 2, all to the power of 1, which is really just 3 over 2. But if it was 2/3 to the power of -3, the first thing the negative would do is turn it into 3 over 2, and then it's all cubed, which means the top is cubed and the bottom is cubed. So that's 3 cubed, which is 27, over 2 cubed, which is 8. Now, a to the power of 0 is always 1. So we're thinking in these terms. For example, 2 to the power of 5 divided by 2 to the power of 5. What happens when I'm dividing the same base? I subtract the powers. And that gives me 2 to the power of 0. But look what I've got. I've got something divided by itself. Anything divided by itself is 1. 8 divided by 8. How many times does 8 go into 8? Once. 100 divided by 100 is 1. Anything divided by itself is 1. And that's why a to the power of 0 is always 1. Let's have a look at these questions. Given that y equals 1/16 x squared, express each of the following in the form kxn, where k and n are constants. Constants means numbers, not letters. Letters are known as variables. They change, they vary. Constants are numbers. So this is y to the power of 1/2, which really means the square root of y. But y is 1/16 times x squared. And therefore the square root is applied to every single part. The 1 is square rooted, the 16 is square rooted, and the x squared is square rooted. And that gives us 1/4 x, just x. Now the square root of x squared is just x. Of course it would be x to the power of 1, but we don't need to write that. And then for b, it's 4y to the power of -1. Y is to the power of -1. So 4 times y, I put it in brackets, x squared, all to the power of -1. Well, this -1 is applied to each part in the bracket. Just like when we had something like this, we applied the power to each part, so it became 5 cubed times x squared cubed. We multiply the -1 to this and to that. So I keep the 4. 4 is being multiplied by the bracket. 1/16 is a fraction, and fractions turn upside down. It becomes a 16/1, but 16 divided by 1 is just 16. And then what happens to x squared to the power of -1? Well, I multiply those two, so it gives me x to the power of -2. And this is a multiplication, so this I could remove the bracket and put a multiplication instead. So I've got 4 times 16, which is 64, x to the power of -2. I don't need to turn it to 64 1/x squared, because they told you to keep it in this form, so not to keep it as a fraction.